Okay, find the three inequalities represented by the straight lines on this grid. Let's look at the line x equals 4 first, which is a vertical line through the x-axis at x equals 4. Now, the region R is to the right of this line. So our shading for this line x equals 4 will be to the right. Now, the inequality that represents values of x to the right is greater than. If you take the x value of 4 and we look to the right of 4, 5, 6, 7, 8, 9, 10, 11. As we move to the right of a value on the x-axis, values of x are getting greater than. So the fact that R lies to the right of this line x equals 4 means that we're talking about values of x that are greater than 4. So the first inequality will be x is greater than 4. Now, specifically looking at the line, which is dotted, means that we have the absence of the inclusivity. If we had greater than or equal to, then that line x equals 4 would be a solid line. But the fact that the inclusivity is that over there, is absent means that the line is dotted or dashed. So the first inequality will be x is greater than 4. Let's look at the line 10y plus 8x equals 80. So it's the solid line. Now the fact is that R, the region, lies below this line. Okay, and values below a line indicate, well, the inequality rather, is less than or equal to. So it's less than or equal to. The fact that this line is solid means that we have this inequality here, less than or equal to. Less than because the shading, the region R, lies below that line, so it's less than. Equal to because the line is solid. So our equation is 10y plus 8x equals 80, but instead of that equals, we are going to have the inequality less than or equal to 80. So this inequality, 10y plus 8x, is less than or equal to 80. Give us shading below that highlighted line. And the last line is 2y equals x minus 4. And we can clearly see that the shading is above that line, which is indicated by greater than or equal to. The fact that this line is dotted means that we're going to be working with this inequality, greater than. Greater than because the shading is above that line, and that inclusivity is absent because the line is dotted. So we take the inequality, take the equation, 2y, just write down 2y, x minus 4, and we have to have the inequality because the region R lies above this line. It will be 2y is greater than x minus 4. And again, the absence of the inclusivity is because the line is dotted. So those are your three inequalities. Question 2. Required to write down the three inequalities that define the region R. So we have a straight line, a solid straight line, highlighted in blue. We have a dotted straight line, highlighted in yellow. And a solid line, horizontal line, highlighted in green. And these straight lines enclose the area R. So if we just look at R, we shade, to get the region R, we shade below the blue line, we shade below the yellow line, and we shade above the green line. So we just have to find the equation of these straight lines and then use the appropriate inequalities to write down the three inequalities that define this region R. So let's take the blue line first. Now we need to find the equation of this line. So you need to find 2 points that lie on the line. How do you find the equation of a straight line? You need to know the gradient of the line and a point that lies on the line. So y equals mx plus c. Let's take this point here on the y-axis, which is 0, 1. We'll find another point on that line. We'll take this point over here. We'll call that point B, and that's going to be 1, 3, then point A will be 0, 1. Okay, we're first going to find the gradient of AB, 3, y2 minus y1, 3 minus 1 over x2 minus x1, 1 minus 0. There'll be 2 over 1, which is 2. So y equals 2x plus c, and c is 1, because that's the y-intercept of the function. So y equals 2x plus 1. So this is the equation of AB. So this line, this blue line, is y equals 2x plus 1. We're now going to find the equation of the yellow line. B lies on the yellow line as well. So we'll just write that point down, and we can use this point here, which in C will be 5 over 2, 3 over 2. So the gradient of BC is y2 minus y1, 3 over 2 minus 3 over 2 minus 3 over x2 minus x1, 5 over 2 minus 1. 1.5 minus 3 is minus 1.5. 2.5 minus 1 is 1.5. So the gradient of BC is negative 1. Y-intercept of the yellow line is 4. We can read it off the graph. So y equals minus x plus 4. This is the equation of the yellow line. So we'll just call that line CD. And then finally, we need the equation of the green line, which is a horizontal line passing through 3 over 2 on the y-axis. So this line will be y equals 3 over 2. Now that we have the equations of these lines, we can now find the inequalities represented that give the region R. Okay, so the region R, we take the green line first, we shade above the green line, y equals 3 over 2, because the region R lies above that line. So the first inequality we'll write down will be y is greater than or equal to 3 over 2. Greater than because the region R lies above the green line, and equal to because that green line is solid. The yellow line, the shading, the region R lies below that yellow line. The equation of that yellow line, which is the equation of CD, the equation of CD is y equals minus x plus 4, but we are shading below this line, which means that y is less than minus x plus 4. The line, the yellow line, is dotted, which means the inclusivity is absent, so it's just going to be less than. And finally, line AB is the line y equals 2x plus 1. The shading is below that line to give region R. So below that line means that y will be less than 2x plus 1. But that blue line is solid, which means we need the inclusivity. So y will be less than or equal to 2x plus 1. Question 7. By shading the unwanted regions of the grid, find and label the region R that satisfies the following 4 inequalities. X less than or equal to 3, x greater than or equal to 2, y is less than or equal to 2x plus 1, and y is greater than or equal to 4 minus x. Now let's identify all of these lines. We need to, in order to know where the feasible region is. Start with x equals 3. We can sketch the line, well, the line x equals 3, highlighted line. X is less than or equal to 3. The inclusivity means that the line is solid, but all the lines have been sketched as solid, and all the inequalities are inclusive. So x less than 3 means we're going to shade to the left of this blue line. Just lightly shade to the left. X greater than or equal to 2, we're looking at the line x equals 2. So that will be this red highlighted line. X is greater than or equal to 2, so we shade to the right of this line. So we lightly shade to the right of that red line. Y is less than or equal to 2x plus 1. So the line that was sketched is y equals 2x plus 1. We just need to look if we make x 0, y is 1, so we mark y equals 1, and when y equals 0, x is minus a half. If we extrapolate this line, we'll get to minus a half. So clearly this is the line that we are working with. So we'll highlight that orange line, and y is less than or equal to, so we shade below this line. So we shade accordingly like that. And finally, y is greater than or equal to 4 minus x is clearly the only remaining line there. So we'll just highlight that purple line, and y is greater than or equal to, which means we're shading above that purple line. So we just lightly shade above the purple line. So now we need to shade a region that satisfies every single one of these inequalities. So we shade to the right of the red line, to the left of the blue line, above the purple line, and below the orange line. So the region we are looking at is what we are highlighting in yellow. This is our region, satisfied by those 4 inequalities, which we mark as R. Cambridge wants you to shade the unwanted regions of the grid, so we just shade around that yellow highlighted region.